Topic 6.5 Other metal processing. One of the metal processing that has been used increasingly is powder metallurgy and can be divided into conventional powder metallurgy, powder injection molding, and additive manufacturing. The process involves mixing metal powder with binder as a lubricant and then forming into desirable shape, finally to give the strength to the product by sintering or heating up to the temperature not exceeding the melting temperature of the metal. And this picture gives you some idea about sintering process. We're starting with metal powder as the particles packing close together. Once we increase the temperature towards the right hand side, neck begins to form along the boundary of the particle, and that makes the pore size reduces significantly. Further increasing in temperature will completely get rid of porosity, so we can have the density of the sintered product up to more than 95% of theoretical density. And the process down here in the picture shows the additive manufacturing. Up here is the laser source that scans in the direction from the left hand side to the right. The metal powders are placed on the bed as in the green state, and once the laser scanning moving to the right, the laser beam as the high heat source will sinter the metal powder along the way. So once the metal powder has been sintered, as you can see from the left hand side of the laser scanning position, so the metal powder has been sintered as a solid metal. The picture on your right hand side can show you a bit more realistic about the additive manufacturing, that the laser beam directing onto the metal surface and building up the solid metal layer by layer. Also up here we can notice a 3D structure that can be built up by additive manufacturing. Although the process can take a bit of time, but nowadays it has been faster, and maybe in the near future we can adapt this process in the industrial scale. Of the metal processing that I'll be talking about that is very important is metal welding or metal joining. It can be divided into two categories. The first one is the fusion welding, and the second one is the solid state welding. So for the first type of metal welding is fusion welding. For example, electron beam, laser beam, and plasma welding. So in this type of fusion welding, we use different sources of the energy. Therefore, we use electron, laser, and plasma as the heat source. As you can see from this picture, that the welder joining the metal piece by means of fusion welding. And picture on the top, you can see that the metal parts on the top and the bottom have been welded along the circumferential by using the filler. So fusion welding is to join or to fuse two or more materials by heating them to its melting point. And therefore, the obtained structure is the cast grain structure. It can also be done with or without metal fillers, depends on the configuration and also the heat source. So this picture in the middle shows how the weld structure has been constructed. So according to the picture, the weld configuration is the butt joint welding. So we have two ends of metal to be welded together. By applying the heat source from the top, the heat source will directly melt down the metal structure here in the fusion zone, creating the weld pool, and as it solidifies, will form the weld metal. And away from the heat source, from the middle, the amount of heat is lesser than in the middle. So in this area, we have the heat affected zone or HAZ. And far away from the heat affected zone is the base metal that has not been affected by the heat from the heat source. So overall, the weld structure consists of the weld pool that the fusion zone is created to finally form the weld metal. And second is the heat affected zone or HAZ that is further away from the weld pool, and the base metal that is far away from the heat. This picture demonstrates how the weld microstructure affects mechanical properties of the metal joint. As you can see here, the weld pool is created up here and also on the downside here. The microstructure of the weld pool is the large columnar grain that is directions towards the heat extraction direction. Along here is the heat affected zone, where the metal has not been melted but affected by the heat, and the temperature is high enough to cause phase transformation in this area. Therefore, the property in the heat affected zone is different from the weld metal and also different from the base metal. And normally the base metal has been mechanically formed, so its property is superior to that of in the weld metal and the heat affected zone. So it's more likely that if we use the weld structure under mechanical load, failure normally initiate within the weld metal because of the cast structure that is larger than other areas, as you can see from this picture. And once the crack started, it will grow very quickly and then finally cause the final or global failure. Another type of metal welding is the solid state welding that consists of diffusion welding and friction welding. First, the friction welding, we can apply the frictional force to obtain high heat that can melt two metal pieces together. If you first notice the picture on the top here, that we have two cylindrical rod shape, one that is fixed for non-rotating part, another has been rotating according to the arrow, and by applying the pressure, the friction occurs on the interface between the non-rotating and the rotating part. During the friction welding process, then the upset is formed. Towards the end of the process of friction welding, the two metal pieces are welded completely. Another type of friction welding is the friction stir welding that has been increasingly used for automotive applications. For example, if you want to weld two metal plates together, in the process of friction stir welding, while putting on the pressure or the load through the pin onto the metal sheet in the butt joint configuration, once the pin is rotated in a high speed, it's moving in the forward direction. By this means, we can produce the weld line that can give high mechanical strength. So in the close-up picture, you can see that the machine-driven die pushes the rotally tipped or the probe into the metal, and that the spinning probe generates heat and mixes the metals together. So while moving forward, the die rotational and linear speed are critical to the process and vary depending on the metals involved. So in the close-up picture over here showing how the friction softens the two metals along the weld path into the doped state without melting them. And for the final, diffusion welding. Diffusion welding provides coalescence of the fairing surface by applying the pressure and the temperature. And picture on your right hand side over here showing the cladding of two materials on the surface. And for diffusion welding, we need the pressure and temperature in case we want to apply diffusion welding onto metal A and metal B. So by this setup, we can use the electrical resistance to provide heat to join the two plates of metal by diffusion bonding. So in summary, for metal processing, we can conclude that the metal extraction is a high energy process that produces metal from ore. And next, the first metal has to be passed through the steel making process. Is when the iron is converted into steel by means of carbon reduction. For the metalworking process, it offers parts with high strength and mechanical fiber structure. And for the last process of metal casting, it is favorable for large complex shape forming that is suitable for metals with low melting point. And finally, by looking on to this diagram, we can see that the metal processing is in the middle that relates very closely to mechanical properties of the metal parts and also to the microstructure after forming.